Here we go, number 4. It's, again, this time it didn't say equivalent ratios or what's equivalent. It said proportional, which we know is just the same as equivalent ratio. So it's like,
Oh my.
okay, so we are just finding if this ratio, hey, if this ratio of sugar to cinnamon is the same as these ratios, we can simplify them to a unit rate. This is already a unit rate, 4:1, and we can divide these to see if they also come to 4:1. 0.25, 6 divided by 1.5, 10 divided by 2.5, and 16 divided by 6. So we're simplifying these all down to be how many parts of sugar for every 1 part of cinnamon. This one, I can just tell it's not going to simplify down to 4. 0.25 goes into 4.5 way too many times. 1.5 goes into 6 4 equal times. So this is proportional. This is not proportional. 2.5 goes into 10 exactly 4 times. So that's going to be proportional. And then 6 times 4 is 24, so that does not go in evenly. So that is not proportional. All right, so this one was just seeing if you know that when it says proportional, it's just meaning equivalent ratios. All right, number 5, go ahead and try that one. Back at it. Number 5. Okay, it says that the ranch charges $17.95 per hour to rent horses. There's no upfront fee. There's no starting cost. So just 1 hour is going to be $17.95. And 2 hours looks like 35. 90. Thank you for putting that extra 0 in there because we're talking about money. So we need 2 decimal places. Get those. Come on. Oh, it is. 53.85 is that the next one? All right, and then final one. Jason, what do you get for that final one? An 80-cent tray. Good. Okay, so if we simplified all these ratios down to the unit rate, it would all equal, right? $17.95 for 1 hour, $39.90 for 2 hours, and so on and so forth. If we did all of these ratios, they all equal that $17.95 per hour, right? Same unit rate all the time, same ratio. Equivalent ratios means proportional. So the total price is proportional to the number of hours. So part B, we're going to write proportional because we have a equivalent ratio. All the quantities, every pair you make with those 2 quantities create an equivalent ratio. Proportion. Oh. All right, next one. Okay, this is just saying determine whether the relationship between each pair of quantities is proportional. So we have to have an answer for both of these. If we find out if these are all equivalent ratios, we can use division. When we divide those, they all come out to an equivalent unit rate. So this is, yes, that is proportional. Okay, so we make our ratios and we see if they're equivalent. These are not equal ratios when we divide. So we'll say non-proportional. They're at lunch. And why our example, our answer is that this gives us equivalent ratios and not equivalent ratios. All right? There you go. For number 7, it can be a little confusing because it doesn't really tell you what quantities we're comparing. This first one is comparing the total cost for 1 pizza. And that's comparing it to the number of toppings. So now knowing the 2 quantities we're counting and seeing the relationship, now we can kind of see more easily if it's proportional. So if we were to go like this with the number of toppings here and then the total cost here, what would, if we get 0 toppings, how much would that cost? That pizza. Yeah, it's still $8.50. Right there, I noticed something that tells me if it's proportional or not. Okay, remember how a proportional relationship has to go through the origin, 0, 0? Yes. Does this go through 0, 0? No, it starts at 0 toppings is already $8.50. Okay, so if we put 1 topping on it, it'd be $9 because we increase it by the 50 cents per topping. All right, 2 would be $9.50. All right, 3 would be 10. If we find all these ratios, they're not going to be the same number. Okay, so there are not equivalent ratios here, and it doesn't go through the origin. Right? It has to make sense that 0, 0 would be on that, in that table or on that graph if we were to graph it. So this is a big fat no. So we look at that next one. We have the health club charges $55 per month. If we were to make a quick table there of the number of months versus the how much it costs, we would be, 0 would cost 0. 1 would cost 55. 2 would cost 110. And if we simplified these ratios, it would all simplify down to that original unit rate, 55 per month. Okay, so that's a yes. This next one, I can look at it and just be like, oh, no. All right, that's a no. Because it's per hour, there's a per hour fee, and there's that other flat fee that if you were to ride that bike for 0 hours, you rent the bike and you haven't even used it at all, you still owe that flat fee. They won't even give you the bike unless you pay the $25. Okay, so right there, it doesn't go through the origin. And then if we go for 1 hour, we're going to add on $2.50 to that. So if you go to 2 hours, you have another $2.50, which would give us, $30. Okay, and then we can also check to see if these ratios are equivalent, which 30 divided by 2 is going to be 15. So that's not even close to 2750 divided by 1. All right, so that would be a no, and you can see it because of this flat fee that starts you off right at 0 hours. You're already paying money. Okay, this gives it to you this next one gives it to you in a different form. They just tell you a bunch of pairs for that quantity. And if you simplify all those to get the miles per hour, they all come to 65 miles per hour, so that's a yes. And then finally, we see just a unit rate of $15 per hour for each hour. And again, if we were to make a table, if you got 0 hours, you get paid $0, 1 hour 15, 2 30, and that would simplify. It starts at the origin and goes with equivalent ratios here, so that's a big yes. Okay. So the next one, we're checking to see if water funds pay like process is the same, is proportional, or is Super Ski's payment plan proportional. Well, so we can kind of like cover this up for a sec, forget about this, and then just look at this chart here. It starts at 0, 0, so that's good. It also simplifies all of these down to the same unit rate of $20 per hour. So water fund is proportional, yes, but it's Super Ski. So now we're going to go to Super Ski, forget about this one, and we look at this first unit rate, or the first pair, and that's already not 0, 0. So we know that that is not. And then if we were to divide all of these ratios, they wouldn't be equivalent. So we do not have a proportional relationship. And then explain your reasoning. So you would put something like this. Water fund is a proportional relationship because it starts origin and has equivalent ratios. Go. Now, this one we have, they gave us a part. They gave us a part to part here, so we can figure out that it's actually our part. But then they told us a whole. They told us how many total flowers. So then, if we made a part to total or whole, okay, if we wanted to, it'd be one tulip out of every 5 flowers. All right. So 1 out of every 5, or we could say if there's 1 out of every 5 are tulips, so tulips out of total, then how many out of 20? Well, looks like times 4, so times 4. So we get 4 tulips, leaving 16 to be roses. Now, some of you did some other things. I see Jason has another way to do it. You could also say, well, this gives us 5 flowers, a total of 5 flowers. If we did 2 and 8, that'll give us a total of 10 flowers. If we did 3 and 12, right, we're just multiplying the originals, because that's how we can work with ratios. 3 and 12, that gives us a total of 15. So if we do 4 and 16, that gives us a total of 20. So that would be our answer. So you can do it like that as well. 4 tulips, 16 roses. Write it down. Make sure you understand some way to do it. Number 10 seems confusing at first, but we're using proportional reasoning. So that means we can set up equal ratios. Or if we have equal ratios, there's a special name for that type of equation. It's called a proportion. So we can set up proportions. This first proportion, we're going to do Earth compared to Mars. So E compared to M. All right, and the table tells us that 150 pounds on Earth is 57 pounds on Mars. So once you see it once, I'm sure you'll be able to do it with the other ones, because all you need to do is pick out the right information and then solve your proportion. So in this case, we've got 85 pounds on Earth, and it's asking us how many pounds on Mars. So we can cross multiply, because cross products for equivalent fractions are always equal. So those two things have to equal the other two things, the product of the other two things. So multiply 57 by 85, and then divide by 150. That comes to 32.3 pounds. Now the rest of them. All right, so I set all of these up, and I'll just go over how we set those up. We'll go over it with this last one right here. All right, I love to see this table is just showing you if you weighed something on one planet, then you would weigh another amount on another planet. So if you're 57 on Mars, you'd be 168.7 pounds on Neptune. So these are all of our first ratios. We choose the ones that we need to help us solve. So for this fifth one, we have to compare Neptune and Jupiter. So I take my numbers from the chart here. If I'm 168.7 on Neptune, then I'd be 354.5 pounds on Jupiter. So that ratio can help us solve for, well, if I'm 90 pounds on Neptune, how many pounds would I be on Jupiter? All right, so that's how we use this proportional reasoning to set up a proportion and solve. Then we just cross, multiply, and divide and get our answer. All right, so have them all there. See if you can set them up on your own, and then try to, and then you can check with my work to see if you know what you're doing. Then you got to ask questions, then you got to try it again. Like, there's a whole process to learning. All right, I'm probably going to be interrupted, but that's okay. We are finding the unit rate, and then we use the unit rate to write an equation. All right, so to find the unit rate, it's I talked to you about having cost usually on top, because we want to find out how much one pepper costs. as opposed to how many peppers you can get for $1. That doesn't make as much sense, and it's not as useful. So we do the 440. We want to find the cost per pepper. When we divide, we get 55.55. It's helpful if we label that because it helps us understand what we're doing. That's the cost per pepper. All right, we want to make sure we have a label there. Okay, and then we want to write our equation relating the cost C to the number of peppers P, and we know how to set up an equation because we know it's going to be y equals kx, where that's my unit rate or constant of proportionality. But they said to use C and P instead. So I believe that we put C here and P here because the cost always equals 55 cents times the number of peppers. Okay, so if we do C equals 0.55 times the P, that is our second part of that problem. That gives us our equation, and it's an equation for a proportional relationship. That's any equation in this form, quantity equals a number times another quantity. That is the form for a proportional relationship equation. All right, then we can use that equation. How much would Sarita pay for 12 green peppers? Oh, it's 55 cents per, so you can just know to multiply, or you can say the cost always equals 55 cents times the number of peppers, which is 12. So we use the equation from up here to help us solve. And that comes to $6.60 for 12 peppers. All right, and our last one, we're going to find the unit rate on this table. You guys are so good at this. You go find a nice point. Maybe this is a nice point, but this is better. If we have our coordinates of 2 boxes for 12 markers, and we find that ratio, y over x, remember? Y over x, we get 6. What does that mean? 6. What? 6 what? 6 what? Yeah. Yeah, look. Y, the y is the number of markers. The x is the number of boxes. So that's markers per box. All right.